Why are tornadoes so windy? We know that supercell thunderstorms are behind some of the most violent tornadoes on Earth. But here's the surprising part. Scientists still aren't completely sure how these twisters actually form. A new idea might help fill in the blanks, and it comes from an unlikely source: cosmic rays from space. Let me explain. When high energy particles from space, known as cosmic rays, slam into Earth's atmosphere, they create a shower of other particles. One of those particles is the muon. Muons are kind of like heavier cousins of electrons, and they constantly rain down on us from above. Now, here's where it gets interesting. They can pass right through thunderstorms and even tornadoes and still reach the ground. Scientists have been running computer simulations of supercell storms, and the results suggest that areas of low air pressure inside these storms play a big role in triggering tornadoes. The problem is, getting direct measurements inside a tornado is pretty much impossible. You can't just drop a weather balloon into one of these beasts and expect it to survive. But muons could offer a clever workaround. Because muons are sensitive to air density, they react differently depending on the pressure in the atmosphere. In low pressure areas, like the center of a forming tornado, the air is less dense, which allows more muons to pass through and reach the ground. By setting up a detector and measuring how many muons hit it during a storm, scientists can get a sense of the pressure inside the storm from a distance, possibly even several kilometers away. The team behind this idea ran simulations using both cosmic rays and storm models. Their conclusion? You'd need a detector that covers an area of about 1,000 square meters. That might sound massive, but it's actually doable. Cosmic ray detectors much larger than that already exist. One in India, for example, spans 25,000 square meters and has even used muons to detect the electric activity inside thunderstorms. Of course, there's a trade-off. A detector that big would have to just sit and wait for a storm to wander nearby. So the researchers are also considering building a smaller, portable version, about 100 square meters, that could be driven to wherever a severe storm is predicted to hit. This wouldn't be the first time muons have been used to study storms. They've been used to measure pressure changes inside cyclones before. But tornadoes are much smaller and more intense, so it's a tougher challenge. Some scientists are skeptical. They wonder if these detectors can really be made portable, and whether the technique will work in real-world conditions. We might find out soon. The team is preparing to test this muon method during the next storm season. If it works, it could offer a new way to peek inside tornadoes. No storm chasing required. That's it for today, and thank you for watching. And as always, have a Voltastik day.